Hey Chem30s, it's Manchak here. I just wanted to record you a quick video to sort of show you something that I didn't include in my lesson, but I realized afterwards that I probably should have, just to alleviate some confusion. Again, it's something I would have covered normally if we were in face-to-face as you guys started to work through the first couple of worksheets, but we're not face-to-face. So this is in regards to drawing compounds out once you've been given the IUPAC name and you need to draw the concepts out. There's sort of three different ways that we can draw those compounds. We can do something that's called just a full-on structural diagram, which includes all the carbons and all the hydrogens that you can see in that compound. You can do a condensed diagram, and you can do a line diagram. And so what I wanted to show you guys is I've kind of done examples of condensed and line diagrams in the first worksheet. This is worksheet 1 of alkanes, alkenes, and alkynes. And I didn't do the fully expanded one, and I'll show you why. This down here, this is cyclobutane. And this, if you count, is heptane. But this isn't even a fully expanded one. But what it is showing is it's explicitly showing all of the hydrogens that are on there. If you guys were going to draw a fully expanded version, then you'd actually put a C here instead of having the apex of the corner of this square, or you'd have a C here, a C here, a C here, a C here, and a C here. I find these kinds of diagrams to be tedious to draw out, but if it helps you to make sure that you've drawn something properly, by all means do it. Okay, what I have up here, these are the same compounds, right? This is heptane, 1, 2, 3, 4, 5, 6, 7 carbons in a chain. This is cyclobutane. But what I've done is done what's called, I call a condensed diagram, where instead of explicitly drawing out each of the hydrogens attached to each of the carbons like we've done in these examples, what I've done here is condensed this. So you can see that there's a carbon with 2 hydrogens attached to it, a carbon with 2 hydrogens attached to it, a carbon, 2 hydrogens, carbon, 2 hydrogens, carbon, 3 hydrogens, carbon, 2 hydrogens, etc., etc. The condensed diagrams are the ones that I tend to use most frequently because it's a little bit more explicit to show you what's going on. So there's a condensed diagram. This is a condensed diagram. This is a condensed diagram, and so on. Okay. The other way we can do this is using line diagrams, and a lot of students I find like to use line diagrams, so you can ignore these for now. Maybe I'll just move these out of the way. These are line diagrams of the same things down here. I don't mind you using line diagrams. In fact, I would encourage it, but only do it if you're really comfortable with ensuring that you understand how a line diagram works and you understand where all the hydrogens are. So personally, I would start here, or even with the condensed version before I move on to the line diagrams. But if you feel like you're comfortable to move on to the line diagrams, then by all means. All you need to remember on these is that each point represents a carbon. And each terminus represents a carbon. So that's a carbon here because it's a terminus. This is a carbon here because it's a point, and so on. The zigzag pattern comes from the fact that we're actually incorporating a little bit of stereochemistry into this. We're incorporating the fact that the shape around here is tetrahedral for this one, except we're not seeing the hydrogens coming in and coming out. I may be able to show that to you guys in these. No, maybe on these ones if I select them, I may be able to show you the stereochemical on them. I don't think I can, not easily at least. Let me see if I can add a stereochemical. No, I don't see it easily for me to be able to do it. But there's some stereochemistry going on here, right? There's an AX4 structure around here. So you're going to have 2 hydrogens or 4 things attached to this carbon here, as well as 3 other hydrogens. And they're all going to sort of be on different planes. two on the same plane of the page, one coming out, one going in. And so that gives us this general structure. And when you guys start to build your molecular models in the activity I've asked you to do, you're going to see those structures come out as well. So all I'm trying to say is when we get to a terminus or we get to a point, each one of those things represents a carbon. Okay, if you want to draw that way, that's fine. And that's sort of what I've shown you here. This example, just for fun, is actually what I drew up here. So this structure here is 1, 2, 3, 4, 5 carbons for the parent chain with a methyl group coming off of carbon 3. So here is your expanded diagram, and you would actually have C's written at each of these points here. And then it would be what your line diagram looks like. So 1, 2, 3, 4, 5, and then your methyl group coming off here. And then if you wanted to, you could also do a condensed diagram. So CH3, CH2, CH, CH2, CH3 with a CH3, which is an alkyl group up there. So I hope that helps. Remember, this is an expanded version of something. This would be your condensed structural diagram. And then if I go back to here and I hit this, this would be your line diagram. You can use any one of those to draw. Just make sure you're doing it right, especially those diagrams, those line diagrams, because they can be quite challenging to draw on their own. So I hope that clears it up. If you have any questions, track me down in my office hours or fire me an email and we can chat. And we'll talk again soon.